And the implicit differentiation, make sure you would have watched the video on implicit differentiation in the link before. And now we're doing the worksheet of implicit differentiation. So this says find the gradient of the curve x squared plus y squared plus 4y equal 21 at the point 3, 2, and hence find the normal at this point. So now what we need to do is, it says find the gradient of the curve. We know gradient of the curve is dy by dx. So first thing we're going to do is differentiate both sides with respect to x. We have to differentiate both sides with respect to x. So we have to differentiate x squared plus y squared plus 4y equal 21. We're going to differentiate all of this with respect to x. Now when you differentiate x squared, what you get is 2x plus, when you differentiate y squared, what you get is 2y, but then you have to times it by dy by dx. That is implicit differentiation. So we times it by dy by dx. Then when you differentiate 4y, you get 4 dy by dx. So you get 4 dy by dx. And then that is going to be equal to, when you differentiate a constant 21, it is equal to 0. Yes, yes. So now when you do that now, you need to make dy by dx a subject. So bring over the 2x over there and factor out dy by dx. So I'm going to factor out dy by dx from those two terms, factor out dy by dx from these two terms, and I'm left with 2y plus 4. Yeah, man, that's dy by dx. But then at the same time, I can bring over this 2x to the other side to get minus 2x. Yeah, man. And so what that work out to be is then dy by dx. If I divide both sides by 2y plus 4, what I'm getting is dy by dx is equal to minus 2x over 2y plus 4. That is dy by dx, minus 2x over 2y plus 4. Now after we do this to find dy by dx, what do we need to do? Well, what we need to do now is we need to find the gradient at 3, 2. So remember, dy by dx is what? Always remember, dy by dx is gradient of the tangent, which is gradient of the curve. So all we're going to do then is at 3, 2, at the point 3, 2, we're going to plug in x as 3 and y as 2. So therefore, the gradient of the tangent, which is dy by dx, is equal to minus 2 times, that is going to be 3 over, this is then going to be 2 times y is 2, so it's 2 times 2 plus 4. And that is going to give you the gradient of the tangent. So the gradient of the tangent is working out to be minus 2 times 3 divided by 2 times 2 plus 4. And that works out to be, I'm really having a little, let me see. I'm just going to bring up the calculator right here. This is a calculator. I'm going to let the calculator do it for me. It's minus 2 times 3. This is being divided by 2 times 2. And this is plus 4. So that's minus 3 over 4. That's what we get. Minus 3 over 4 is the gradient. Minus 3 over 4. So that is minus 3 over 4. So since the gradient of the tangent is minus 3 over 4, we're really good now. Yeah, man, we're good. Gradient of the tangent is minus 3 over 4. So that's the gradient at 3, 2. So let's tell them in words that we know that's the gradient. So we can tell them that is the gradient at 3, 2 is minus 3 over 4. That's what we can tell them. Nice. Now, what is the next thing they wanted? They said they want the normal at 3, 2. So to find the normal, remember the gradient of the normal is minus 1. Gradient of the normal is minus 1 over the gradient of the tangent. And so that means that the gradient of the normal is equal to, that would be 4 over 3. 4 over 3. Yep. And so what would be the equation of the normal? So the equation of the normal will be given by, I'm not going to simplify it. Equation of the normal is going to be given by y minus yp. So equation of the normal will be y minus the y value at the point, which is 2, y minus 2, and it's equal to 4 over 3 times x minus xp, which is x minus xp, which is x minus 3. That's what we get. That would be the equation of the normal. Easy, soft. This is the equation of the normal. No difficulty whatsoever. Nice. All right, soft. So that's the equation of the normal. Equation of the tangent, x squared plus 5y squared plus 2x equal 4 at the point 1 minus 1. They want the equation of the tangent. So first thing we know we have to do is differentiate both sides with respect to x. So when you differentiate both sides with respect to x, d by dx means we're differentiating with respect to x. Then what are you differentiating with respect to x? You see I put it in bracket, we're differentiating x squared plus 5y squared plus 2xy equal 4. This is what we are going to differentiate with respect to x. So I make sure to put it in bracket. So when you differentiate x squared, what you're going to be getting is 2x plus, when you differentiate 5y squared, you carry down the power, you get 10y. When you differentiate y with respect to x, you always multiply by dy by dx. That's what we always do. Plus, now, when you're differentiating 2xy, you have to use product rule. Using product rule, we know we keep the first times the differential of the second, which is dy by dx, plus keep the second times the differential of the first. So when you differentiate 2x, you get 2, that is 2y. This is equal to 0. Yeah, man, that's what we get. Now, since that is what we get now, oh, kind of good, what do we do now? We try to make dy by dx the subject. So we observe we have 10y dy by dx and 2x dy by dx. We're going to write dy by dx, and we're going to factor out dy by dx from those two terms. Factoring out dy by dx from those two terms, we have 10y plus 2x. Yeah, man, we have 10y plus 2x. And this is going to be equal to, we bring over everything else to the other side. So we have minus 2x minus 2y. That's what we get. And so now what we're getting is dy by dx. What we're getting then is dy by dx is going to be equal to minus 2x minus 2x minus 2y over 10y plus 2x. That's what we're getting. Over 10y plus 2x. Yeah, man, that's what we get. And so now, in order to find the equation of the tangent, we know that dy by dx is already the gradient of tangent function. So to find the gradient at the point 1 minus 1, all we need to do is plug in x as 1 and y as minus 1. So let's do that. Let us do it. So at 1 minus 1, we know x is 1 and y is 1. So what we're getting is the gradient of the tangent is equal to minus 2 times 1, which is minus 2 times 1, minus 2 times minus 1, over, this is now 10 times minus 1, plus 2 times 1. That will be the gradient of the tangent. Nice and easy, soft. So let us evaluate that. Minus 2 times 1, minus 2 times minus 1. Oops, and look at that. If you work out the numerator, you're going to realize that you're quickly going to get 0. Yeah, man, we're definitely going to get 0. All right, we're going to get 0. Nice, because look at this. Yeah, man, we'll bring it over minus 2x minus 2y. We work this out, we're going to get 0. So that means the gradient of the tangent at 1 minus 1 is 0. Since the gradient of the tangent is 0, it's easy to find the equation of the normal. So the equation of normal is given by, the equation of the normal will be given by, equation of the normal is going to be given by y minus y1, so it's y minus minus 1, which is y plus 1, and that's going to be equal to gradient of the tangent, which is 0 times x minus 1. And so really and truly, the normal will just be y equal negative 1. That will be the equation of the normal, y equal negative 1. If I made y the subject, easy, soft. So that's it. That's the equation of the normal. Now, of course, let 21. Was that the curve? Let me check back again. X squared plus 5y squared plus 2xy equal 4, not 21. Equal 4. Equal 4. This is what we have. And what I want you to observe is I'm going to draw the line y equal to minus 1. No, this is a line. Okay, there we go. Look at that. Y equal minus 1 is a tangent. Only touches this ellipsoid at 1 point. If we look good, it only touches it at 1 point, which is at the point 1, 1. So that is why we can say that this is indeed the tangent, only touching it at 1 point, at this point right here. All right. Yep, that point. This is the curve and this is the tangent at this particular point. Yeah, man. So we know we're good. So this is just verification of the solution that the tangent, I wrote normal, right? Too much normal. Need to fix that. They should have said tangent. Equation of the tangent. So my apologies for writing the word normal. They should have said tangent. That's how we find the equation of the tangent. Y equal minus 1. Nice.